Hello students, let us start a new chapter, that is solid state. Let us discuss the introduction of solids and the type of solid in this video. As we have already discussed that the three states of matter, which are solid, liquid and gases. As we look around, most of the things we see are solid substance rather than the liquid and gases. So, let us recall some of the points which we have already discussed about solids in the lower classes. Let us discuss the force of attraction between these. There is a weak intermolecular forces in gases and liquid. Therefore, they have tendency to flow freely, especially the gaseous particles. Therefore, it take the shape of the container. But in solids, they are tightly packed. In solids, the particles are held together by a strong force of attraction. So, we can say that the particles cannot move randomly like gases. But these particles can vibrate on its mean position. Therefore, solids have vibratory motion only. So, let us summarize the important points of solids. So, from these visuals, we can summarize the important characteristic properties of solids, which are: solids are rigid, have definite shape, mass and volume. The intermolecular distance are short, intermolecular forces are strong, particles have fixed position, particles oscillate, they are incompressible and diffuses very slowly. Let us discuss more details about solids. Types of solids. In this chapter, we are going to discuss the two important types of solids, that is crystalline solids and amorphous solids. Let us do a comparative study of these two solids. Look at the picture. In this picture, the first picture, you can see here some particles are there, which I am highlighting here. These are some particles. Look at this. In this, all the particles are in a regular arrangement. We can say they form a definite geometrical pattern, or we can say these are arranged in a definite order or regular manner. But look at the second picture. In this picture, you can find the particles are not in a regular order. That means they are arranged irregularly. So, because of this reason only, in the first case, we can say that there is a regular arrangement. That means they have a definite geometric pattern. But in the second case, there is no regular arrangement. Therefore, there is no definite geometric pattern. So, from this, what we can conclude that? We can conclude that crystalline solids consist of particles which have a definite geometric pattern. But in the amorphous solids, constituted particles are arranged in irregular pattern. So this is the main reason which makes the two solids entirely different. Look at this structure. In the first crystalline solids, you can see a regular arrangement of particles, and because of this reason only, they melt at a particular temperature. That means they have fixed melting point, or we can say sharp melting point. Let the substance is get melted at the temperature 300 degrees Celsius. But what about the amorphous? In amorphous, there is no sharp melting point, but a range, we can say there is a range in between it start to melt. That means we cannot give a sharp melting point for amorphous, but there is a sharp melting point for crystalline solids. Let us discuss its cleavage property. When we cut the crystalline solid through a sharp edge tool like knife, we can see that it gets into two pieces with a clean cleavage. But in amorphous, when it cut through the knife, we will not get a clean cleavage but irregular cleavage. That is also due to its structural arrangements. In crystalline solids, whatever patterns are there, you can see that patterns are there as it is for a long range. But in amorphous, you can see there will be some regular pattern, but that pattern, you can see up to here there is a regular arrangement of particles, but after that we can see the pattern get changed. So that means the amorphous solids also have some regular pattern, but that regular pattern is for a short range. Then the pattern get changes. But in in crystalline, whatever pattern is that pattern will be continuous throughout the crystal. That means if the pattern is cuboid, that cuboid will be throughout the crystal. But in amorphous, the pattern will changes. That's why it is called as short range order, and crystalline is called as long range order. Crystalline solids and amorphous solids. We discuss one of the property that if when we measure any physical properties such as refractive indexes, if we measure it in different direction, for example, I am measuring a refractive index on this direction, so we'll be getting a particular value. But the same refractive index, if I measure in this direction, then I'll be getting different values. Why it happens so? The same physical property, when it is measured through in a crystalline solid in different directions, will be getting different values. What is the reason for this? Look at the lines which I have drawn here. In the first line, you can see that when I am measuring in this direction, the particles like blue color, you can see the blue particles are on this direction. And what about in the second case? In the second case, you can see the red particles are there on this direction. That means there will be regular arrangement of pattern. So when we find the refractive index or any other physical property in different direction, it lead, and this takes place through the different particles. So we will getting different values. But in the case of amorphous, when you find in any direction, because there is no regular arrangement, so we'll be getting the same value in all the direction. That means some of the physical properties, it shows different values at different directions. Therefore, it is called as anisotropic. But in the case of amorphous, the physical property shows same value at different direction, therefore called isotropic. Here in this definition, shows and direction a little bit changed in the editing. It is not seen, so just correct it. Crystalline solids are actually called as true solids because they exactly behave like solids in all the situations. But the amorphous solids are called as pseudo solids or supercooled liquids. Because why they are called as liquids? Because they have a tendency to flow very slowly. Let us take one example. The old buildings or monuments where you can see glass, the windows which is made up of glass, it is observed that these windows appears to be thicker, these glasses are appear to be thicker at the bottom and thinner at the top. So why it happens? Because these actually, glass is an example of amorphous solid which have a tendency to flow. Maybe you're not going to believe this one, but actually glasses have the ability to flow like a liquid, but this flow is very slow. So when that glass in the windows of old building for long years it is fitted there, and this glass is actually flowing very slowly. So when it is flowing, it becomes thicker at the bottom side and thinner at the top. Therefore, we can say that the amorphous solids are actually not true solids. They behave like a liquid because they have a tendency to flow very slowly. What are the examples of these? That is, example of crystalline solid is common salt. Example of amorphous is glass. Let us do a comparative study here. We can summarize this. This crystalline have regular patterns. Amorphous have irregular arrangement of particles. Crystalline have sharp melting point. Amorphous have no sharp melting point. Crystalline undergoes clean cleavage, but amorphous undergoes irregular cleavage. Crystalline have long order, that is long range order. The other one is short range order. This is anisotropic, amorphous is isotropic. Crystalline is true solids, amorphous is pseudo solids. Example for crystalline solids are common salt, metals like copper, silver, zinc sulfate, amorphous glass, rubber, plastics. So these are the differences between crystalline and amorphous solids. So this is all we have discussed about the two type of solids. So in the next video, we'll be discussing about the classification of crystalline solids. So thank you everyone.